So, hello for another video. So now, the last chapter we tackled is the VLANs. And now we will be discussing the inter-VLAN routing. Okay. So for the introduction, so what will I learn to this module? So the module title is Inter-VLAN routing, and it has the objective of troubleshoot inter-VLAN routing on layer 3 devices. So we have these four topics covered here in this module. We have inter-VLAN routing operation. So the objective of this topic is describe options for configuring inter-VLAN routing. Then we also have the router on a stick inter-VLAN routing. So configure router on a stick inter-VLAN routing. And then inter-VLAN routing using layer 3 switches. So configure inter-VLAN routing using layer 3 switches. Then troubleshoot inter-VLAN routing. So we need to troubleshoot common inter-VLAN configuration issues. So the last time I read this module is I think 3 days ago. So let's see if I remembered some important parts. So the first part is inter-VLAN routing operation. So what is inter-VLAN routing? So VLANs are used to segment switch layer 2 networks for a variety of reasons. So regardless of the reason, hosts in one VLAN cannot communicate with hosts in another VLAN unless there is a router or a layer 3 switch to provide routing services. So in the last topic we tackled about the VLANs, and we just use VLAN for segmenting layer 2 networks, so meaning we don't communicate with the host devices on the other network, so we just communicates so hosts in one VLAN cannot communicate with hosts in another VLAN. Okay, so we are not okay. So in the last topic of VLAN, we can communicate with other VLANs. We're just communicating with, for example, VLAN 10. So in VLAN 10, so I think in this module is we can now communicate in other VLANs through the use of router and layer 3 switch, I think, or the multi-layer switch. So inter-VLAN routing is the process of forwarding network traffic from one VLAN to another VLAN. Then we have three inter-VLAN routing options. We have the legacy inter-VLAN routing, router on a stick, layer 3 switch using switch virtual interfaces. Okay, so this is a legacy solution, this one, so it does not scale well. Now router and stick, this is an acceptable solution for a small to medium-sized network. Then the layer 3 switch using SVI is the most scalable solution for medium to large organizations. So I think the difference between these three is on the topology itself, so we can see it later on. So the first one is the legacy inter-VLAN routing. So the first inter-VLAN routing solution relied on using router with multiple Ethernet interfaces. So this legacy inter-VLAN routing involves a router, of course. So each router interface was connected to a switch port. So you can see here the switch port, the 1 and 12. So in different VLANs. So the router interface serves as a default gateways. So this interfaces here and here. So this is the default gateway. And then the VLAN subnet. So for example, refer to the topology. So we have here. Okay, so this one is assigned to VLAN 10. It's connected to R1. Okay. So this is the trunk. I think this is the trunk. Okay. MAC address table for S1. Let's see the important part. this. Legacy inter-VLAN routing using physical interfaces works, but it has significant limitation. So it is not reasonably scalable because routers have a limited number of physical interfaces. So I think we have the interface, so maximum of 4 gigabit interfaces and just 3 serials interfaces. So requiring one physical router interface per VLAN quickly exhausts the physical interface capacity of a router. So we can see here that this VLAN accumulates this one interface already, and then this one. So the interface of a router is very limited. So what if there were 6 or more VLANs to interconnect? So a separate interface will be required for each VLAN. Obviously, this solution is not scalable. So the second one is the router on stick inter-VLAN routing. So the router on stick inter-VLAN routing method overcomes the limitation of the legacy inter-VLAN routing method. So it only requires one physical Ethernet to route traffic between multiple VLANs on a network. Okay, so we have here multiple VLANs. So where's the VLAN 10, the VLAN 20, 30. So they are just using one interface of a router. Okay, they're using sub interfaces. So they use the gigabit 0/0/0, and then they subdivided it. We have 0.10, 0.20, 0.30. Let's see. Okay. Nothing but okay. Sub-interfaces. So specifically, the router interface is configured using sub-interfaces to identify routable VLANs. So configured sub-interfaces are software-based virtual interfaces. So which is associated with a single physical Ethernet interface. So they are just using this interface for all the VLANs. Sub-interfaces are configured in software on a router. Each sub-interface is independently configured with an IP address and VLAN assignment. Okay, sub-interfaces are configured for different subnets that correspond to their VLAN assignment. Click play to figure router stick performance routing functions. Okay, let's see. Okay, Unicast addressed goes to switch VLAN 10. Okay, came from the VLAN 10, goes to router Unicast VLAN 30. So the port it came from, it is also the port where it comes out. So single interface. I think that is a reply. Reply to 10. Okay. VLAN tag frame. Goes back to VLAN 10. Okay. So as seen in the animation, PC1 on VLAN 10 is communicating with this PC3 on the VLAN 30. So when R1 accepts the tag Unicast traffic on VLAN 10, it draws the traffic to VLAN 30 using its configured sub-interfaces. Okay, so switch S2 removes the VLAN tag of the Unicast frame and forwards the frame out to PC3 on port 23. VLAN tag, the Unicast frame. So the router and stick method for inter-VLAN routing does not scale beyond 50 VLANs. Okay, it also has the limit of 50 VLANs. The routing on stick, router on a stick. So inter-VLAN routing on layer 3 switch. So we're now using this multi-layer switch. Okay, so this multi-layer switch are capable of routing frames on different networks. Okay, the modern method of performing inter-VLAN routing is to use switches. So it's also called the multi-layer switch. So inter-VLAN's SVIs are created the same way the management VLAN interface is configured. So the management VLAN interface, so we're using the IP address and subnets. Okay, the SVI is created for VLAN that exists on the switch. So although virtual, the SVI performs the same functions of the VLAN as a router interface. Okay. So the interface of this works like a router. So it's like a router and a switch. Multi-layer switch. So these are the advantages of using layer 3 switch. So much faster than a router on stick. No need for external links from the switch. External links from the switch to the router for routing. So we don't need router anymore. So we just need the multi-layer switch. Okay. They are limited to one link because layer 2 Ether channels can be used as strong links between the switch. So latency is much lower than commonly deployed campus LAN routers. So the only disadvantage is that layer 3 switches are more expensive. Layer 3 switches, let's see. Layer 3 switch. Cisco Meraki multi-layer switch. See, this is the multi-layer switch. Haha, easy network. So now check your understanding inter-VLAN routing. This is different scenario for each question. Click each button for the inter-VLAN routing operation scenario that corresponds to the question. Okay, check your understanding of inter-VLAN routing. So it's one question. Refer to each scenario topology. Which statement best describes the different types of inter-VLAN routing solutions? Choose all that apply. So we have here the multi-layer switch, and it is the inter-VLAN using. So this is a scenario A, is a layer 3 inter-VLAN solution. Next is so it uses two interfaces. So it is the router on stick. No, the legacy. So it's a legacy inter-VLAN. Okay. I think this is the router and switch. Now this is the router and switch. Router on a stick. So it uses sub interfaces on a router. So it's scenario C. So let's check. Okay, exactly. So next, router on a stick scenario. Okay, this topic details how to configure router on a stick inter-VLAN routing. You can see in the figure that the router is not the center of the topology, but instead appears to be stick near the border, hence the name. Okay. So in this topology, there are trunk links between these two switches and then the router. So it's just a link for transporting VLAN information. We have R1 sub-interfaces. We also have the first interface here, then the interface here, and then interface here. 1 and 2. It is also this link. This is a sub-interface also. This is also a VLAN. This is also a VLAN. Wow. Okay, we have here, assume that R1, S1, S2 have initial basic configurations. So currently PZ1 and PZ2 connecting each other because they are on the separate networks. So as you can see, they have different VLANs here and different IP address. Where are we? So only S1 and S2 can ping each other, but are unreachable by PC1 or PC2 because they are also on the different network. So they are on the same network, obviously, as you can see. So .99.2 and .99.2. Okay. The interface here, the interfaces for both switches are on the same network. S1 VLAN tracking configuration. These are the steps. Why this so large? So we have here the steps. So first, step 1 is create and name the VLANs, then create a management interface, configure access ports, and configure tracking ports. And we have here this guide. First step is create and name the VLANs. So we have here the commands. So we're just naming management. Okay. So create the management interface on a switch. So on a switch interface, S1. So what is this? It is a router on a stick. So first one is we need to create the VLANs. So we have the 3 VLANs here, and then so I think on the last module we don't configure this as a VLAN. I think it is the first time of making this a VLAN, the link between 2 switches. So create the management interface. So in the S1, on the switch 1, we just configure this interface. We include or we add some IP address and subnet mask. Okay, and then we also configure the IP default gateway, so which is the interface of this router. Configure access ports, so this is the access ports, the 6 and the 18. So also enable the port by no shutdown command. The last step is configure trunking ports. So this is the trunking ports. So they are the links that is used for forwarding VLAN information. So interface F01 and F05. 01. Okay, for the switch 1, 05 switch port mode trunk. Okay. So that's it. So S2 VLAN. Okay. S2 VLAN trunking configuration. So the configuration for S2 is similar to S1. So I think the only difference is it did not configure the R1 because it is not directly connected. So we just name the VLAN, just name the VLANs. So we have here 3 VLANs. So every time you add the information of the VLAN here in this switch, so we also need to add the information for the switch and router. I think router is also included. So here in the S2 or the switch 2, we also configure the interface VLAN 99. So the management LAN here, 01, interface VLAN 99. So we add the IP address, we also configure the default gateway, and then interface 18. Okay. So the 18 here, the port 18 here is the unaccess port. So mode access, then it access the VLAN 20 only, and then the mode trunk, no shutdown. Also, we need to configure the sub-interface configuration. So R1 here. So the router on stick method requires you to create a sub-interface for each VLAN to be routed. So a sub-interface is created using the interface, then interface ID, sub-interface ID, global configuration mode. So the sub-interface syntax is the physical interface followed by a period and a sub-interface number. So as you can see on the previous example, we have the interface 00/0/0.10.20.20. So that is the sub-interfaces. So although that not required, it is customary to match the sub-interface number with the VLAN number. So for example, we have the VLAN 10, VLAN 20, VLAN 30. So the sub-interface number is the 10, the 20, and the 30. So each sub-interface then configured with the following 2 commands and the encapsulation .1q, and then the VLAN ID. Then I think the native command here is also added, also included in the command. Also the IP address and the subnet mask. So we're just adding the IP address on the router interfaces. So this is encapsulation .1q, and then the VLAN ID. So this command configures the sub-interfaces to respond to .1q encapsulated traffic from the specified VLAN ID. So .1q, I think this is for the LAN. .11q is for the wireless, if I remember. So the native keyword option is only appended to set the native VLAN to something other than VLAN 1. So what is our native VLAN? So I think this is optional. So repeat the process for each VLAN to be routed. Each router in sub-interface must be assigned an IP address on a unique subnet for routing to occur. But we also have different IP address for sub-interfaces. Okay, and when all sub-interfaces have been created, enable the physical interface using the no shutdown command. This is the magic command. So I always forgot this command. So interface configuration command. So if the physical interface is disabled, it is shut down. So all sub-interfaces are also disabled. So now we have here the example. So this is the one that we are configuring, this 0/0/1. Okay. So the first thing we do is interface G0/0. So this is the interface ID, then the .1 or the sub-interface ID. So as mentioned earlier, so the sub-interface, a best practice is to have a same sub-interface number and the VLAN number. So description, so we also have the description. So for example, default gateway for VLAN 10. So it's also a good practice including of description for better documentation. then the encapsulation to funnel example encapsulation that one too, then the VLAN ID, then the IP address. Okay, we also have different IP address for different interfaces, sub-interfaces. Tier 10, okay. 99. Okay. Trunk link. Whoa. Interface. Okay. So this is the interface here is already a trunk. Let's see. It's already a trunk. Configure trunk ports. Here, the F1. The F5 support mode trunk. So it's already configured with trunk. So verify connectivity between PC1 and PC2. So this is just a configuration. Verify connectivity of host and another VLAN using pin command. So it is a good idea to first verify the current host IP configuration using ipconfig. Okay. Successfully confirms if their VLAN routing is operating. Okay. So when you receive a reply, so obviously it is connected. Router and stick Inter-VLAN routing and verification. So we have here the show commands used to verify and troubleshoot the router and stick configuration. Router and stick. Okay, we have here. Okay, we have here the Inter-VLAN using switches. Okay, we just first discussing the router and stick. Don't we have the legacy? So here the show IP route. So CD verify this one. So routing table of R1. Okay. So we can see the IP address, the network here. It's connected through this sub interfaces here. Yeah, this IP address is connected this sub interfaces. So IP interface brief. So the output confirms that the sub interface of the correct IPv4 address configured. They are operational. So I can see there's VLAN sub interfaces. So their status is up. We also have the show interfaces. Let's see. For example, show interfaces. So this interface, the output is based on this interface only. So LAN protocol is up. Show interfaces trunk. Okay. So the output confirms that the link to R1 is trunking for the required VLANs. So let's see. VLANs allowed on trunk. So this port is both on and selection is trunking. Okay. So both the fast Ethernet 1 okay, this is configured on the switch 1. So this tree is the configuration in the router. The last one is for a switch. Okay, so this packet tracer is included on the last video, so I'm not doing it yet. So it is on queue. Okay, we don't have exam. Check your understanding exam. Now for Inter-VLAN routing using layer 3 switches. Okay, so it's connected to hosts on different VLANs. Okay, this is directly connected, but we have a different VLAN here. Okay, we have an IP address. So the VLAN 10 and the VLAN 20. So these are the steps in creating. Someone message on our coronavirus group chat. So layer 3 switch configuration. Complete the following steps to configure S1 with VLAN trunking. Mask safe. Let's see. I'm just replying for the. Let's see. Okay. So the first step one is to create the VLAN. Second step is create the SVI VLAN interface. Step 3 is configure access ports and enable IP routing. So we are configuring the multi-layer switch, I think, directly the multi-layer switch. So we have the D1. So we need to create the VLANs here. The VLAN 10, so name 10, VLAN 20. Okay. So create the SVI VLAN interfaces. Okay, interfaces VLAN 10. So it's quite confusing because in this multi-layer switch, so it's like we're configuring a switch and router on the same time. So here the interface VLAN 10 and the VLAN 20. Interface VLAN 10 and VLAN 20. So this part is like a switch. Then description. So we're adding a description in these interfaces. I think this is for the router. Then we are adding. Okay. Shut down. So the first one is we need to create the VLANs, and the second one is we need to create the SVI VLAN interfaces. Okay. Next is we just need to configure the access ports. Then we have here the two access ports, the 0/6, 18. Wow, it has so many ports compared to a router. So I have here the 6 gigabit internet, and then the 18. We add the description, switch port mode access, and then switch port access VLAN 10. So obviously it's a switch. We can do switch things, but it's like we're configuring a router. So enable IP routing. Okay, it's just a single command, one line command. You just need to add the IP routing. So enable IPv4 routing with the IP routing global configuration command to allow traffic to be exchanged between VLANs 10 and 20. So this command must be configured to enable inter-VLAN routing on a layer 3 switch port for IPv4. So basically, if this is not configured, the PC on a different VLANs cannot communicate with each other. So it's that simple. So layer 3 switch inter-VLAN routing verification. So I think in this part we will verify the configuration. So it's show commands. Okay, so using ipconfig, subnet mask, the default gateway. Okay. That's it. Okay, they're just ping each other. So routing on a scenario layer 3 switch. Okay, I think this is the routing configuration on a layer 3 switch. What is this? Layer 3 switch. Okay. So we're just configuring this switch, but now on this example, we are now configuring the whole network. Okay. It's much more complex. It's now connected to R1. Okay. So and R1 and D1. So these two are both in open shortest path first. So routing protocol domain. what's this one? So I think I did not mention this. So Assume VLAN is implemented on D1. Routing configuration layer 3 switch. So complete the following steps to configure D1 to route with R1. Okay. So in the first example, we are just routing between these two VLANs. Now we will be using a router connected to the multilayer switch. So first, step 1 is configure the routed port. Step 2 is enable routing. Step 3 is configure routing. Step 4 is verify routing. And step 5 is verify connectivity. So I need to click it button. So the first one is configure the routed port. Configure the G1/0/1 to be routed port. Assign it to the IPv for it. C101. 101. I don't see 101. Port link to router 1. I think this is the what they're talking about, G0/0/1, not Ethernet 0/. So then that 2. Okay, that 2 and that 1. Okay, so this is the network address for the link of these two. Okay, they use the /24 for just two interfaces. So the first one is configure the routed port. So we just add an IP address on the multilayer switch. So in the interface of a multilayer switch. Next is we need to enable routing. This is the single line command. Next is configure routing. Wow. So this is configure the OSPF routing protocol to advertise the VLAN 10 and VLAN 20 along with the network that is connected to R1. So don't think OSPF, just ignore it. So it is a must. But routing, it is a routing protocol. Okay, so we just need to add this on our configuration for us to be able to connect to this to the network connected to R1. Okay. Configure routing. Okay. So network, then the network, we have here the network 10 and the 10, the 20. Okay, so this network is for the VLAN 10 and VLAN 20. Is this the subnet mask? 0.0, area 0. What is that area 0? Area 0. I think that is the first time, that is our first time seeing that area 0. So, just configure it. Area 0, area 0. Okay. Just add that. Then verify routing. So we need the show IP route begin gateway. So 10.20.20.024. Okay. Gigabit Ethernet 1. 10.10.10.1. Okay. So this network is connected to the R1. This is the interface around R1 via Gigabit Ethernet 1/. Okay. We also need to verify connectivity. So the first one is to configure the routed port, and then enable routing and configure routing. Configure the routed port. So the packet tracer. I think we will add. So doing packet tracer is very important. So it adds some additional knowledge. Also, some of the most important things that I read in the module is found in the packet tracer. So I learned much on doing packet tracer. So we just need to video it. So why not common Inter-VLAN issues? So I think this is the last one. And then the module practice and quiz. Okay, troubleshoot Inter-VLAN routing. Common Inter-VLAN VLAN issues. We have the missing VLANs. So we have the how to fix, create or recreate, ensure host port is assigned to the correct VLAN. Then we also have the commands to verify it. We have the missing VLAN. So we have the show VLAN brief, show interfaces switch port, and also the ping. Then switch trunk port issues. So how to fix? Yeah, what's trunk port and enable. Show run config. So we can interface trunk. So in these commands we can see that if our trunk ports are already configured, switch access port issues. So we can fix it by assigning correct VLAN to the access port. So host is incorrectly configured in a wrong subnet. Also an issue. Show interfaces switch port. So we can use this two commands for this issue. Like I'm sneezing. Router configuration issues. Show IP interface brief. So in the router show interfaces. Troubleshoot Inter-VLAN routing scenario. So we have here the scenario. Have here sub interfaces. So missing VLANs, we have the show VLAN brief. So have the missing, I think we have the missing VLAN. PC1 is currently connected to VLAN 10. So as you can see, okay. So assume the VLAN 10 is accidentally deleted as shown in the output. The reason is because okay, the VLAN 10 is the one we have deleted. So the fast Ethernet 6 becomes inactive. Okay, creating the missing VLAN will automatically assign the host to it. Let's see. As shown in the following output. Missing VLAN. I think this example we don't have. Okay. Notice that the VLAN has not been created as expected. Okay. So in this example, we just create the VLAN 10 and then we show VLAN brief. So as expected, so the VLAN has not been created. So the reason is because you must exit first from VLAN sub-configuration mode to create the VLAN as shown in the following. So we just need to first exit and then verify. Switch trunk port issues. We have this show interfaces trunk. Okay. So as you can see, on running this command, the show running config interface, we can see that this interface here to the bus Ethernet /5 is shut down. So we just need to enable it. Switch access port issues. Okay. Okay, access mode VLAN. VLAN 10, okay. Router configuration issues. Verify the sub-interface status using the show IP interface brief. So notice that 0.10 is incorrectly assigned to VLAN 10 instead of VLAN 100. Okay. So we just need to re-enter the command for 10 encapsulation that one. So I just forgot it, the .1 queue. Okay. .1 queue. So this is for router. Okay. Check your understanding. So this question is for. So we also have the packet tracer. So I already downloaded this. So I think we can answer it tomorrow or the other day. So tomorrow I will be heading on Batangas City as we will doing our commercial Damask. So you are troubleshooting an Inter-VLAN issue on a router and need to verify that the interfaces are in a routing table. So which interface VLAN routing troubleshooting command is this. Show IP route. So we can see the routing, the paths on the router. Okay. So the router is the keyword. We still have the show IP route. So you are troubleshooting an Inter-VLAN issue on a switch and need to check the list of VLANs and their assigned ports. So which Inter-VLAN routing? List of VLANs. Show VLAN. Have the keyword. So you are troubleshooting on routing. Verify the status of an access port in access mode VLAN. Status of access port. Show IP interface brief. And this is the access port, switch port. Verify the status and IP addresses of all interface. Show IP interface brief. We have read the IP address. Let's check. Okay. So we have here the lab troubleshooting. So now we have the whoa, something went wrong. What? No, we're doing the module practice. Yes. So we also have the packet tracer for module 4. So what did I learn in this module? We have the Inter-VLAN routing operation. We have the 3 types. So the first one is the legacy, then router on a stick, and then the layer 3 switch, which is the layer 3 switch using SVIs. Okay, router on stick, Inter-VLAN routing. Okay. Then we also learn how to troubleshoot Inter-VLAN routing. Also discuss. So I don't think that you will learn from this. Okay, so module quiz Inter-VLAN routing, we have here 15 questions. So a PC is access a web server on the network. The highest bandwidth of layer 3 will also provide the default gateway for the PC. Access a web server. Provide the highest bandwidth. Multilayer. Inter-VLAN. So, which scalable method must be implemented in order to provide Inter-VLAN routing with more than 1000 VLANs? Connecting a router interface to a switch port that is connected in a trunk mode to route traffic between. So, onto router interface. So this one is like router on a stick. So it has the limit of 50 VLAN. So I think this is not the answer. Configure static routing traffic internally to layer 3 switch device. Physical router to different physical switch port. Layer 3 switch device. So when configuring a router as part of the router and the stick Inter-VLAN, where should the IP address be assigned? Configuring a router as a part of interface. To the sub-interface, we have the router and the stick Inter-VLAN routing. So small college uses VLAN 10 for the classroom network, VLAN 20 for office network. What is needed to enable communication between these two VLAN? We're using legacy Inter-VLAN routing. So the legacy we have here, the router. Okay. A switch with the port that is configured as trunk is needed to connect. What is needed to enable communication? I think a switch with the port is I think this is the answer. So what is the disadvantage of using multi-switches? So it is more expensive. So which type of Inter-VLAN communication requires the configuration of multiple? Requires the of multiple sub-interfaces. Router on a stick. So the router on the stick is the only Inter-VLAN with sub-interfaces. So when using multi-layer switch, we just assign the IP address on the VLANs. So what is the disadvantage of using router on a stick Inter-VLAN routing? Yeah, it does not scale well beyond 50 VLANs. So last 8. That's the meaning of number 10. So it is the VLAN ID. So while configuring Inter-VLAN routing switch, so network configuration, which is the no switch port command. What is the purpose of this command? No switch port. To operate a routed port. No switch port to provide the access. To create a routed port for a signal network. To provide a static. Provide static trunk. Okay. No switch port. So I think this is our initial password, initial answer. So network administrator enters the following command sequence on a Cisco switch. What's the purpose of this command? To shut down, to make switch SVI or routing port. So if I answer this, the answer is this. Okay. Switch SVI. Let's see. So what operation mode should be used on a switch port to connect it to the router? Trunk. SVI Inter-VLAN routing. An SVI is needed for which VLAN? How is traffic routed between multiple VLANs on multiple layer switch? Internal VLAN interfaces. What is required to perform router on stick Inter-VLAN routing? A router that is ito. So, network administrators, okay. Troubleshooting a router on a stick topology and completed was related to configuration of VLANs and router sub-interfaces. Which two commands can be used? Choose two router sub-interfaces. Show IP interface and show running command. Let's check. Okay. We got correct here. Port routed. Okay. Okay. So we only have one wrong answer with this. Small college uses VLAN 10. What? Legacy. This is our first answer. Let's see. Check. So I just changed my answer on that part. So I think that's it. So all the packet tracers here will be included on the packet tracer playlist, and next topic would be STP concepts. So I haven't read this, so maybe later I'll be starting studying this or reading this. So it's